A great day to one and all. I am Kim JC Show, and today I will be speaking or talking with you about some special problems involving permutations. So this will be a special type, the set of problems that I will be giving you involve permutation, but in this case, there are some restrictions about this. And if you wish to know more about permutations, I suggest that you watch the previous video, the lesson related to this one, especially the basic topics involving linear permutation. How about if there are some elements that are being repeated or involving circular permutations? I suggest that if you haven't watched that yet, or if you don't know them yet, I suggest that you watch them first, and I will be giving you the link in the description box below. So with the assumption that you have already watched that video, let us discuss some of these problems. Let us recall that when we speak about permutation, it refers to the arrangement of a finite number of objects where order is important. That is, if you swap or switch places or positions with with any two elements at least, then that becomes a different arrangement. For example, if I have 1 2, 1 2 is different from 2 1. So here order makes a difference in terms of meaning. And today I will be exploring, or I will be speaking with you some problems that involve such. Are we ready? I hope we have our pencils, our pens, our papers with us. And if you wanted to pause the video from time to time to try on your own, go ahead. Now, let's have an example. Amy, Ben, Kara, Donald, and Ella wanted to occupy a row of 5 chairs. In how many ways can they sit? A. How about in all? If Amy and Kara are next to each other, meaning they are beside each other, and that no one is between them. If Amy and Kara are not next to each other. If all the girls are together. If all the girls are not together. If people of the same sex are seated next to each other. Or how about if people of the same sex are not seated next to each other? You could see that C, E, and G are like you just place not to them. And for letter H, if they are seated alternately in terms of sex. Note that for this problem, we have the assumption that Ben and Donald are the boys, and the rest of them, namely Amy, Kara, and Ella, are the girls. Feel free to pause the video if you wish to try these problems on your own. And if you are ready, resume playing the video, and I will be revealing with the solution with you now. Let's have the first case. How about in how many ways can these 5 people sit in all? So for the solution for this, we could see that there are no restrictions about seating arrangement. Meaning to say, anyone could sit anywhere in all of those vacant seats. And since in this particular case, repetition is not allowed, for example, if Amy was already on the first seat, or if Amy is already occupying the first seat, it is also presumed or known that she can no longer occupy the second, third, fourth, or fifth seat. So this one, it's just simply 5 factorial ways. That is, 5 people could sit on the first chair. If the first chair is taken, 4 could sit on the second chair. If the 2 people have already seated, then 3 people could sit on the third chair, 2 on the fourth chair, and if the 4 people are seated already, then the remaining person has no choice but to occupy the remaining seat. Hence, that's 5 factorial ways or 5 times 4 times 3 times 2 times 1, or 120 ways. Hence, there are 120 ways to occupy the vacant seats. All right. Now, how about if given the same situation, if Amy and Kara are next to each other, meaning to say they are beside each other, they are adjacent to one another. So for the solution for that, I will represent A with Amy with A, B for Ben, C for Kara, D for Donald, and E for Ella. Let's say we have this one. These are the 5 people. But since Amy and Kara are next to each other, then I will place here a rectangle to indicate that they are seated next to each other. And we have to remember this. If I placed a rectangle here to indicate that they are treated as one, that's why this box here or this here is only counted as one slot. And how many slots are there? So we have 1, 2, 3, 4 slots. That's why we have 4 factorial here, because we have 4 slots. 1, 2, 3, and 4. But you might ask, sir, how come there's 2 factorial here? And the answer is simple. Why 2 factorial? Why multiply by 2 factorial? Because Ami and Kara has 2 factorial ways to rearrange themselves as long as they are together. So Ami, Kara, or Kara, Ami in this case. And for such, by the fundamental counting principle, that's why we have to multiply them. And we have 4 factorial times 2 factorial, which is, we know that 4 factorial is 4 times 3 times 2 times 1, or 24. 2 factorial is 2 times 1, or 2. And simplifying this gives 48 as the correct answer. Hence, there are 48 ways all in all for Amy and Kara to sit beside each other or next to each other. Okay, I hope you understand it, or I hope you understood this one. Now, let's have a sidetrack a bit. I listed 25 positive integers, of which 13 are odd. How many of them are even? So we know that an integer, a positive integer, could either be odd or even, right? So if 13 of them are odd, then to get the number of even, what do we do? We simply subtract 13 from 25. Hence, there are 25 minus 13, or 12 ways, or 12 odd, 12 even. So 13 odd, 12 are even out of these 25 positive integers. And you see, no, sir, that's so simple. We all know that. That's good. Because this simple principle will be used rather to answer the succeeding letter C. So in this case, the same situation is given, that Amy, Ben, Kara, Donald, and Ella wanted to occupy a row of 5 chairs. In how many ways can they sit? But this time, if Amy and Kara are not next to each other. So in this case, what do we do here? So remember, the results we have in A and B are really important here. So you could see there are 120 ways in all, of which why 120 in letter A earlier, that's 5 factorial. So there are 120 ways that all of the seats will be occupied. However, out of these 120, 48 of them are the number of ways that Amy and Kara are together. So in this case, that's why we have to subtract. So that is why, hence, there are 120 minus 48 or 72 ways for them not to be seated together. So you see, it's simple. 120 in all, 48 ways for them to be together. Hence, their difference, which is 72, is the number of ways that they are not seated together. If you wish to try out with your friends, you could actually verify all 72 of them. All right. I hope you got the solution. How about letter D? If all the girls are together. So in this problem, all the girls have to be adjacent with one another. And if all the girls are together, then no boy should be between at least two of them. Okay? So, sir, how about the boys? The boys could be anywhere as long as all the girls are together and that no one sits between any of the two girls. So in this case, we have, let's say we have this arrangement. Let's say we have one of these arrangements. We have A, C, E, D, B. Remember in this case that only Donald and Ben are the boys, which means Amy, Kara, and Ella are the girls, right? And since all the girls are together, that's why it's helpful to place a rectangle or like a box to this one. And what's the purpose of the box? To indicate that they are taken as one. Because remember, if they are together, then you have to take their case as only one slot. That's why if the three girls are here, how many slots do you see? If you see three slots, then you are correct. Why three slots? Because we have here 1, 2, 3 slots. That's why we have here 3 factorial. And you might ask, sir, where did the other 3 factorial came from? Why is there another 3 factorial? Because, Amy, we have here inside the box, we have 1, 2, 3 objects. And that there are 3 factorial ways for Amy, Kara, and Ella to be arranged within themselves. So example, you could have here AEC, CAE. There, all in all, there are 3 factorial ways. And by the fundamental counting principle, that's why we multiply them. Hence, we have 3 factorial times 3 factorial. 3 factorial is 3 times 2 times 1, which is 6. So we have 6 times 6, or 36 ways. Hence, there are 36 ways for all of the 3 girls to be together. How about for letter E? If all the girls are not together. So using a similar reasoning earlier, there are 120 ways in all for them to be arranged. But out of these 120 ways, there are only 36 ways, based on our answer in D, that all of the girls are seated next to each other. Hence, by the complement rule, we have to subtract them. Hence, we have 120 minus 36, or 84 ways for all girls not to be seated together. If you answered 84, congratulations, you got it right. Are we ready for letter F? Let's go. How about if people of the same sex are seated next to each other? And when we speak about people of the same sex are seated next to each other,
which means all of the girls are together. All of the boys are also together. No boy is between any two girls, or no girl is between any two boys. So if this is the case, how many ways are there, do you think? So I will reveal the solution in 3, 2, and 1. Let's consider this arrangement again. A, C, and E are the girls, and D and B are the boys. And since all the girls are together, we have to put them inside a rectangle or a box. So to indicate that Ami, Cara, and Ella are together. But remember, Ben and Donald also have to be together. That's why we will putting another box for Donald and Ben. And so, how many slots can you see in all? There are only 2 slots. We have here, because remember, if they are boxed, they are only counted as 1 slot. So we have here 1, 2. So we have 2 slots. Hence, we have 2 factorial here. This is the 2 factorial all about, because we have 2 slots. But you might ask, sir, how about these 2? How come? Because there are 3 factorial ways for A, C, and E to rearrange among themselves. And for Donald and Ben, there are 2 factorial ways. We know that 2 factorial is 2 and 3 factorial is 6. And so we have 2 times 6 times 2, that's 24. Hence, there are 24 ways for these 5 people to sit if people of the same sex are seated next to each other. How about for not? Because in letter G, it's asking not seated next to each other. So in this case, we will be utilizing the answer we got in A and letter F. That is, there are 120 ways in all, of which there are 24 ways that people of the same sex are seated next to each other. Hence, there are 120 minus 24, or 96 ways for people of the same sex that are not seated next to each other. I hope we got this correctly. And let's have letter H. How about if they are seated alternately in terms of sex? When we speak about alternately, let's say boy, girl, boy, girl, boy, girl, boy, girl, and so on, or it could be girl, boy, girl, boy, girl, boy in this case, no? In any case. But let us analyze. Remember, there are 3 girls and 2 boys. So who should be on the leftmost or in the rightmost? Should it be a girl or should it be a boy? We have to analyze this one. Let's analyze the principle. How about if a boy is here? Let's say if Ben is here. If Ben's here and we have here a boy, girl, boy, girl. Boy, girl, but the last here will be a girl. So that can't be, because they should be alternately seated. How about if a girl, so therefore a boy on the first or on the last is impossible. But is it possible to have a girl on the first slot? Let's see. Girl, boy, girl, boy, girl. And that is the only possibility. That is why this is solvable, but only the girls could either be on the rightmost or on the leftmost. So here, we have 3 girls, right? So they have to be seated first. And it's understood here that repetition is not allowed, because if a girl is already seated here, she can no longer sit here and the other one. So there are 3 girls. So the first seat here, the first slot could be occupied by any of the 3 girls. If any one of the girls already seated, are already seated, which means for the third slot, only 2 of them could sit. And if the second girl has already sat down, then that leaves 1 girl left for the 5th slot. So in this case now, the girls are seated already. But how about the boys? So here, there are 2 boys, so 2 of them could sit here. But if one of them has already seated here, so there's only 1 boy left, and that is here. That is why we have 3 times 2 times 2 times 1 times 1, or that's 12 ways in all for them to be seated alternately. Okay? So in this case, you could also, if you want to, 3, 2, 1, that's 3 factorial. 2 times 1 is 2 factorial. So you could also have 3 factorial times 2 factorial, which is 6 times 2 or 12. So you see, it's still the same thing. Are there questions or clarifications? If you do have, feel free to reach me and my social media accounts, and I will be willing to answer them. Or if you wish, you may also comment your query in the comment section below. Okay, so as your exercise, okay, please do this. And I wish you all the best in life. God bless everyone. Take care and a great day to one and all.